This video is going to be another coding stream where I will be coding a Leetcode problem, and let's get started. So the problem is 2sum. Well, this is a very easy problem, but as we know that some FAANG companies have some dumb interviewers who ask these questions in the interviews as a basic testing question. But the idea is not that this is an easy question, but that this problem has an important trick. And the actual fact is that if you know the trick, then the problem becomes easy for you. If you don't, then even the easiest problems are the hardest. So we will understand that how we can solve this problem in n square complexity as well as n log n complexity. So let's get started and understand the problem. As you can see that this problem is 2sum. So here we need to find two numbers in an array such that they sum to a given target. For example, if you see the first input, then it is 2, 7, 11, 15 and the target is 9. So it means that we have to find two numbers inside the array such that they sum up to 9. And there are certain conditions given in the problem that the numbers in the array are all unique and they always sum to a given target. Although we will see ahead in the question that we don't care about that condition, but okay. So in this example, we can see that the first index, which is 2, and the second index, which is 7, I mean the number at second index, which is 7, they sum up to 9. So we will have to return 0 and 1. That is, we need to return the indices of the numbers that sum up to a given target. In the second example, you can see that we have three numbers in the array, 3, 2, 4, which are all unique as given in the constraint of the problem, and the target is 6. The first index number, which is 2, and the second index number, which is 3, that is the second and third element of the array, and arrays are 0 based, 0 indexed, sum up to 6, which is 2 and 4. 2 plus 4 is equal to 6. So in this case, we need to return 1 and 2. In the third example, we can see that the target is 6. The numbers are 3 and 3. So we return 0 and 1 because both the numbers sum up to 6. And as you can see that the length is 10 to the power 4 in the constraints, and the numbers can range from 10 to the minus 10 to the power 9 to 10 to the power 9, and the target is also the same, and only one valid answer exists. So it means that even if there are multiple answers, we need to just return the very first occurrence. And also there's a follow-up. The follow-up is that can you solve this in less than O of n square complexity? Clearly, as you can see that the constraint is 10 to the power 4. That is, the length of the array can be 10 to the power 4, and 10 to the power 4 squared is 10 to the power 8, which can fit perfectly in the time limit that we want, which is I think less than 1 second, I guess. So n complexity works here. Let's go ahead and solve this problem in n square complexity. The solution is very simple and very intuitive, so you don't need to think much about it. You just need to iterate over the whole array, and you need to brute force by choosing two indexes at a time. And if they sum up to the given target, then you have your answer. So for I equals 0 to n and for j equals I plus 1 to n, we are just iterating against all the possibilities that we can have. If the number I plus number j is equal to target, then we can simply return the indexes, which are and j. And although it is given in the problem that an answer always exists, I would argue that it might be the case that there is no answer. So in this case, we can simply return -1 and -1, saying that the indexes are invalid and they don't exist. The problem says we won't encounter this case ever, but I don't like that statement. Whenever you're writing code, you can encounter any kind of problem and you must handle all kinds of errors separately. So let's try running this. It is still running. So clearly it is accepted, and it took like 2 milliseconds and all the test cases are accepted. I will just go ahead and submit this problem. As you can see that the problem is submitted and we have an accepted verdict. It took 28 milliseconds on an average with 3.5 MB of memory. But as you know that this is n square approach and this is very simple. What we want is a better approach, and well, there is a better approach which is possible, and that is using maps. What we can do is we can hash the numbers that we have already seen. So let's say that you iterate over the array and you see a number, you just keep it in the memory, and when you enter some other number, let's just take the first example, 2, 7, 11, 15. So you encounter 2, you keep it in memory or in the map, When you encounter 7, what do you need to see whether you have the corresponding number to 7? So the target is 9, the correct number is 7, so 9 minus 7 is 2, which is the number that you need. So if you have already seen that number before, and note that we have saved the index of that number in our mapping, we can say that we have our answer. So I will just separate the implementation into two different ones. The first one is to sum n square, which took like n square complexity, and the second one is to sum using map, which is the n log n approach. So as I discussed earlier, I will create a map first, which is the index map. It will just store the index of all the numbers we have seen till now. And given that all the numbers are unique, we don't need to worry about two numbers clashing or something. And even if they do, we don't need to worry about it because we just need to find our pair. So even if we have like two twos in the array with different indexes, we don't care if we select one index because in the end, we just need to return one single answer. So what are we going to do here? We are simply going to check in the map that whether we found the number or not, and the number that we need is target minus the current number. So we have these compilation issues. It is because the map first returns the value and then the boolean of whether that value was found or not in Golang. So we need the index first and then the found boolean. Okay, so we have missed a return somewhere. Oh, okay, so we need to just return this because this is a function. It returns some value. We need to return it back. So as you can see that this is accepted again. I will just explain the code in a bit, but first let me just submit this. As you can see, this solution is way faster. It only took 6 millisecond as compared to 28 millisecond in the previous run, and the memory is more because we are now using a map. We are in a way storing the numbers inside the map, but as you can see, the runtime has come down drastically. Now I will just go ahead and explain the solution. So first of all, what we want is that the numbers should sum up to the target. So nums I plus nums j is equal to target. Therefore we can say that nums I is equal to target minus nums j, or we can even say that nums j is target minus nums. What does this mean? It means that if we are at some index j and there is some index I which we have already seen, then nums should be equal to the target minus number at the index I that we have already seen. So if we have encountered the number which is nums I, which is equal to target minus the current number we are at, then we have found our answer. And the indexes that we need to return are the current index, which is I, and the previous index, which is the one that we have already saved in our map. So this problem is a good one to understand the hashing technique. We can drastically reduce the runtime if we can hash the results that we have already seen. In this case, we have already seen a number that we are interested in. Let's call that number an interesting number, and that interesting number should be equal to the target minus current number we are at. And if we have already seen that number, we have already found it, we have already inserted it in our map, we can simply return the index of that number as well as the current index we are at. This is the problem that we have solved just now, and it required some good hashing technique. Although this is an easy problem, but if you don't know this trick in the interview, you are bound to fail, or you will take some time to implement this problem, and the dumb interviewer who is just interviewing you and who has just learned this question, they will simply judge you that you are not able to solve this very quickly. But that shouldn't be our approach. Our approach should be in understanding the technique here, and that is what I'm trying to do.